This is the video 8 of MEKG video series. In this video, purifiers topics are discussed. Topic 1, Principle of Clarification or Purification process.
Separation of solids from liquid is called clarification. The clarification principle is explained by considering an oil settling tank. Oil containing solid impurities and water is transferred to the tank and allowed to stand undisturbed. Over a period, due to gravitational force, the solid impurities and water will settle down, being heavier than oil. The clean oil will be at the top. However, separation by gravity will require longer time. If centrifugal force is imparted to the oil, then the separation force will be higher, and hence the speed of separation will be faster. In a centrifugal clarifier, the oil is supplied through the distributor to the conical disc stack. Solid impurities present in the oil separate out and accumulate at the bowl side. The heavier solids deposit near the bottom of the bowl and the lighter solids towards the top. Only the clarified oil is delivered out of the clarifier. The separated solid impurities and water are removed through the sludge ports during desludging. Purification is a process of separating two liquids, usually oil and water. The separation of solid impurities also takes place at the same time. Consider a tank with a partition at one end. The partition has an opening at the bottom, which allows the liquid to flow through. Water is filled first inside the tank till it overflows from B. Oil is supplied to the tank at A. The oil will displace part of the water, and the amount of water displaced will depend on the relative density of the oil. The oil-water interface will depend on the position of B, that is H1 head of water, H2 head of oil, and the oil density. The equilibrium equation is H1 is equal to the product of H2 and oil density. The position of the oil-water interface should be maintained to avoid oil mixing with the separated water and water mixing with the clean oil. The position of the interface can be maintained by varying the head of water H1 according to the density of oil being purified. Water present in the oil will settle down, causing an equal amount of water to overflow at B. The quantity of water forming the seal remains constant. The separated clean oil will overflow at C. Rotate the tank through 90 degrees and the figure will represent the separation taking place in a centrifugal separator. The principle is similar to the gravitational method. Water is filled first till water flows out at B. Oil is supplied at A and part of the water is displaced at B. The separated water will flow out at B. The separated clean oil will flow at C. H1 is altered depending on the density of the fuel to maintain the oil-water interface. In centrifugal purifier, gravity disk controls the position of oil-water interface. The size of the gravity disk is selected according to the density of the oil to be purified from the maker's nomogram. The purifier is filled with sealing water first. The oil to be purified flows down the distributor and enters the conical disc stack through the supply holes. Part of the water is displaced and the remaining water forms the water seal. The oil flows in between the discs through the distribution holes and the heavier solid impurities separate and accumulate at the bowl side. The separated water from the oil flows out through the water outlet. The purified oil flows out through the oil tank. Purifiers separate liquids as well as solid impurities. Clarifiers separate only solid impurities. Purifiers have separate outlets for the separated water and the purified oil. Only clarified oil is discharged from the clarifier. The gravity disc in the purifier maintains the oil-water interface. In clarifier, there is no gravity disc and sealing water. Since there is no water seal, bowl space is more and the centrifugal settling force is greater due to the increased radii. The discs in purifier contain distribution holes. The discs in clarifier do not have any distribution holes.
Topic 2: Purification system.
The fuel oil purifier is used for purifying both fuel oil and diesel oil. When fuel oil has to be purified, the feed pump takes suction from the fuel oil settling tank. The fuel oil is delivered through the fuel oil heater and three-way circulating valve to the purifier. The purified oil from the purifier flows to the fuel oil service tank. When the purifier feed has to be stopped for desludging, the three-way valve is activated to pass the fuel back to the suction side of the feed pump. When diesel oil has to be purified, the feed pump section is changed to the diesel oil settling tank. The heater is bypassed by opening the heater bypass valve, as diesel oil does not require heating for purification. The purified oil flows to the diesel oil service tank. The main engine lube oil purifier is used for purifying the main engine lube oil and the stuffing box drain oil. The purifier feed pump can take suction from the main engine lube oil sump, stuffing box dirty oil tank, and the main engine lube oil settling tank. The main engine lube oil from the sump is supplied through the lube oil heater to the purifier. The purified oil flows back to the main engine lube oil sump. Purification takes place continuously when the main engine is running. The dirty oil drained from the main engine stuffing box is purified and stored in a clean oil tank. From the clean oil tank, it is transferred back to the sump through a filter. The main engine lube oil settling tank is provided to store the main engine sump oil. The feed pump takes suction from the lube oil settling tank and supplies it to the purifier. The purified oil can again be delivered back to the settling tank or to the main engine lube oil sump for continuous purification. In some ships, where auxiliary engines are run by fuel oil, a separate lube oil purifier purifies the lube oil of the auxiliary engine sump. The specifications of a typical purifier are shown.
Topic 3: Arrangement of centrifuges.
On board, purifiers are arranged in series as shown. The feed pump takes suction from the settling tank and delivers to the first purifier. This purifier removes water and solids in suspension. The purified oil is passed to the second machine, the clarifier, to remove the finer solids remaining in the fuel. This arrangement is suitable for a vessel operating on a residual fuel. This arrangement improves the overall separation efficiency and provides safety margin. In the parallel arrangement, both machines act as purifiers. Both the purifiers take suction from the settling tank and simultaneously deliver the purified oil to the service tank. This arrangement allows reducing the throughput of the purifiers. The low throughput permits a longer time for fuel purification.
Topic 4 ALCAP.
ALCAP separators are used for purifying fuel oil of specific gravity more than 0.991. When oil is fed into the system through the oil inlet, the separated water and sludge accumulate at the bowl periphery. The purified oil is discharged through the oil outlet. It operates similar to a clarifier. However, the separator uses a flow control disc instead of the standard gravity disc, as the difference in specific gravity between the water and the fuel oil to be purified is less. A water transducer is situated on the oil outlet side. It senses the water content and activates the control unit. When the accumulation of separated water increases, the water approaches the disc and part of the water is carried over with the clean oil. The water transducer senses the water in the oil and sends a signal to the control unit. The control unit opens the water drain valve. The accumulated water flows through the hole in the flow control disc and drains through the valve. The accumulated water can also be removed through the sludge port along with the sludge during desludging. The control unit is programmed to keep track of the number of times drain valve opens and the time elapsed after the last desludge cycle. Accordingly, the control unit drains the water through valve or by desludging.
Topic 5 Cross-section of a purifier.
This sketch shows the cross-section of a purifier. Draw the axis of the purifier vertical shaft. Draw the vertical shaft. Draw the control pairing disc and the connecting water pipes. Draw the spring support, springs, dowsing ring, and the operating slide. Draw the ball body, and sliding ball bottom. Draw the distributing con. Draw the inlet pipe and the distributor. Draw the ball disc stack. Draw the top disc. Draw the level ring. Oil pairing disc. Clean oil outlet pipe. Gravity disc. Upper pairing disc. And the water outlet pipe. Draw the sealing water inlet. Draw the ball hook. And the large lock ring. Label the parts.
Topic 6 Operational Procedures.
Specification.
The purifier you see is a typical fuel oil separator with a throughput of maximum 4 cubic meters per hour. The purifier feed pump takes suction from the fuel oil settling tank. The fuel is delivered to the fuel oil heater and three-way circulating valve to the purifier. The purified oil flows from the purifier outlet to the fuel oil service tank. The purifier and the feed pump can be started from the local control panel. The operating water tank is situated at a predetermined height. The water flow to the purifier is controlled by the valves. Before starting the purifier, you have to carry out a few checks. Checking whether the operating water level in the tank is full. Insufficient water in the operating water tank will lead to improper bowl closure. This results in loss of oil to the sludge space. Check whether the oil level in the gear case is up to the prescribed mark. If the oil level is low, it will lead to friction and damage to the moving parts. Check whether the brake is released. If the brakes are on, then the purifier will never achieve the rated speed and separation is hampered. Open the feed pump suction and delivery valves. If the feed pump is started with the suction valve closed, the pump will run dry and the bearings may seize. Check whether the heater inlet and outlet valves are open. Open back pressure regulating valve at the outlet of the purifier. If the oil is supplied without opening the back pressure valve, the oil will overflow from the water side. Start the purifier. The motor current increases to a maximum value. It gradually decreases to the rated current as the purifier attains the rated speed. Open the operating water to close the bowl. Open the sealing water until it flows from the water outlet. Check the desludging operation of the purifier. Shut the operating water cork. Open the desludging water cork for 5 seconds and shut the cork. As soon as the bowl opens, you hear a thudding noise. The motor amperage rises at the start of desludging operation and then returns to its normal value. If the amperage does not rise, then it denotes that the bowl has not been opened for desludging. The fuel oil should be heated up before purification to reduce the viscosity as per maker's specification. Start the feed pump. Oil from the feed pump will circulate through the heater and the three-way valve back to the suction side of the pump. Open steam to oil heater. Too low or too high oil temperature results in breakage of water seal and loss of oil from the purifier. Open the operating water. Open the sealing water until it overflows from the water outlet. Open the oil feed by positioning the three-way feed valve to the purifier. The oil will displace part of the water inside the bowl through the water outlet. The purified oil flows from the purifier to the service tank. Set the back pressure as suggested in the manual, either by throttling the discharge valve or by controlling the throughput. The back pressure is the pressure at the oil outlet of the purifier. Back pressure is essential for proper pumping of oil to the service tank and maintaining the water seal. Check temperature of the fuel oil. The fuel oil temperature is maintained in the range of 94 to 98 degrees centigrade according to the viscosity of the oil. If the temperature of the oil increases more than the boiling point of water, the water seal will break. This will result in oil overflow. Monitor the oil inlet pressure to the purifier. The inlet pressure will indicate the throughput. Decrease in the set inlet pressure indicates that the feed pump filters are dirty. The back pressure should remain the same as set while starting. If the back pressure decreases, it indicates oil overflow or oil leakage to the sludge side or decrease in the throughput. Check through the side glass that is located on the water outlet pipe. Only separated water should trickle out of the water outlet. Oil should not flow through the water outlet. Oil overflow will occur due to the loss of oil sheath. Check the oil level in the gear case. Top up if necessary. Lack of lubricating oil will lead to friction and damage of the moving part. Shut the oil feed by positioning the three-way valve to the feed pump suction. Shut the steam inlet and the outlet valves to the heat and stop the feed pump. Open the sealing water. The water will displace the oil inside the bowl and overflow through the water outlet. Close the sealing water. If the sealing water is not opened, it results in loss of oil. Desludge the purifier to remove the sludge present in the bowl. If the desludging operation is not carried out, it entraps all residual sludge within the purifier. Stop the purifier after desludging. Close all fuel valves. If the valves are left open, it will lead to loss of fuel.
Topic 7: Sludge Discharge Mechanism.
You will now see the basic functions of a purifier. After the purifier has attained its full RPM, the bowl closing water, also called the operating water, is supplied at the bottom. Sliding bowl bottom is pressed upwards against a seal ring by the hydraulic force of the operating water. The sealing water is now supplied to the sealing water inlet. The supply of sealing water is continued until it comes out of the water outlet. The dirty oil is supplied into the bowl to the dirty oil inlet. Due to centrifugal force, the oil displaces the water and the sludge to the bowl periphery and rises upwards through the disc stack. The clean oil is then discharged through the clean oil outlet. Sludge and water particles accumulate at the bowl periphery and separated water is continuously discharged through the water outlet. The sludge ports in the periphery of the bowl are covered by the sliding bowl bottom. For desludging, oil feed inlet to the purifier is stopped and the operating water is closed. The bowl opening water, also called the desludging water is supplied for a few seconds, during which the water flows on from the top of the operating slide. The water force exceeds the spring force and pushes the operating slide downwards. The entire operating water is discharged through the nozzle. This causes the sliding bowl to move downwards, thereby opening the sludge ports. The sludge is discharged through sludge ports. The cycle is restarted and the operation continues.
Topic 8. Troubleshooting.
If the oil overflows from the water side, it indicates that the water seal is broken. The reason could be very high oil inlet temperature. Inspect the temperature controller and the steam inlet valve of the heater. Rectify the defects in the heating system. Improper selection of gravity discs will shift the oil-water interface towards the periphery, resulting in oil flow to the water side. Select the correct gravity disc. Oil overflow can also be due to low speed of the bowl. Inspect the friction pads and replace if necessary. If the oil throughput is less, it may be due to the malfunctioning of the feed pump's relief valve. Overhaul and adjust the relief valve. Choked filter in the feed line may also lead to reduction of oil throughput. Inspect and clean the filter. Clogged pipeline can also be a reason for low oil throughput. Clean the pipeline. If the operating water pressure decreases, the bowl will not close properly and oil will leak to the sludge side. The operating water pressure will reduce if the waterline filter is clogged. Clean the waterline filter. The choked pairing disc will reduce the operating water pressure. Inspect and clean the pairing disc. The operating water can leak through the worn-out O-rings and the bowl will open, allowing the oil to sludge side. Inspect and replace the O-rings. Heavy vibration may be due to the accumulation of sludge and bowl imbalance. Inspect and clean the bowl. Inspect the shock vibration mountings. Desludging water may not flow due to the faulty operation of solenoid. Inspect and replace the solenoid. Choked water line filter also blocks the flow of desludging water. Clean the filter. The rise in back pressure may be due to constriction in the purifier outlet piping, high throughput, or low inlet temperature. Inspect and take corrective action. Improper selection of gravity disc will shift the oil-water interface towards the center, resulting in water flowing through the oil slide. Select the correct gravity disc.